Hello and welcome to Pixel Particle Palooza. Our goal with this project was to make a generalized multi-particle simulator, capable of replicating many different types of particle dynamics, as well as the interactions between those particles. The pipeline for this project starts with a JSON file, which specifies the parameters for each simulation. This includes particle types, what they look like, how many there are, and how they interact with each other. This data is then stored in a particle properties class, which dictates the shared properties for particles of a certain type. For the simulation itself, each particle in the scene references the properties based on its type. We use relay integration and also factor in collisions between particles and primitives. Particles can even turn into other types of particles when they collide. To render the scene, we first make a scalar field based on the relative densities of particles at each location. We then use the marching cubes algorithm to generate a mesh which surrounds the particles. We've modified the algorithm to also factor in what particle types are present at each location, in addition to the raw density value, so that the mesh can be colored based on the particle type. Finally, we apply shaders, usually cell shading, and then render the entire scene to a temporary frame buffer, which is run through one final post-processing shader to create the final pixelated result.
Here is our final product, what we chose as the best simulation we were able to create. In this simulation, you can see fire at the start blazing up. It does this through the use of an internal force that, for particles nearby, fire particles are propelled upwards. It is then extinguished by water falling from above. Water falls under an external force of gravity, and when water and fire particles collide, they turn into steam and rise to the top. And so I think one of the interesting things we learned is that doing multi-particle simulation at the level we did is actually pretty straightforward. Not to say that it was easy, but we did not shoot for a high level of realism in either the physics or appearance, but were able to produce a large number of interesting simulations.
I mean, I think that there's a lot of potential with a project like this. I mean, we were able to accomplish a lot with our simple kind of cartoony style, right? But, think of what you could do if you had like a...
If you could combine like realism into it.
Yeah. Like, what if you had like realistic looking water with like incompressibility, right?
I mean, I feel like the end goal of multi-particle simulations would be something where you can simulate just actually the real world at the atomic level.
No, that would be pretty wild. I feel like it'd also be like incredibly inefficient though. I mean, part of the reason that particle simulators usually work is because they're optimized for something specific, right?
True. But that's why it would be so much impressive.
It would be
so much
pretty
more
rad.
impressive if you could do it.